record on this. And so you might receive a little notification because I'm starting to record where you have to hit continue. So if you receive that little box on your screen, please hit continue because it will kick you off. So hopefully no one got kicked off. If you did, I'm sorry, and hopefully we'll see you coming back, but I am recording now. And so, as I said, my name is Hannah and I'm the program director for Cold Harbor Institute. And just to provide a little background for those that don't know Cold Harbor, or those that want a refresher, Cold Harbor kind of has two places that represents it. And one is the ranch, which is about 7 miles east of Gunnison. It has a homestead on it. And then we also have an office at Western Colorado University in Gunnison as well. And so today, the Applied Sustainability Program, which is a program part of Cold Harbor Institute, is going to be presenting through Cillian, who is the owner of Hearth, sorry, Cillian, if I mispronounced this, of Hearth Design Built. And he's also a collaborator with Habitat for Humanity. And he's going to be talking on, he's one of our collaborators, he's one of our stakeholders, and he's going to be talking on resource conscious construction. And so before I introduce Cillian, I just want to remind you that we do have another speaker series coming up, another webinar coming up on November 9th at 6 p.m. And this one is going to be talking about local investing with soul. So if you want to learn more about that, you can visit our website, and you can also register for that event through Eventbrite off of our website as well. So be sure to be looking out for more details about this upcoming webinar, again, happening on November 9th at 6 p.m. So Cillian, I want to give yourself some time to kind of introduce yourself and to get going. So if you are willing to start sharing your screen, that would be great.
Great. Thank you, Anna.
Yeah, of course. Let me make you co-host. Let me know if you have any troubles sharing your screen.
Can you see that?
I can.
Okay. Great. Well, thank you for the introduction. Yeah, little correction. It's hearth, like a fire hearth design build.
Thanks for that.
Yeah. So today I want to talk about resource conscious construction, past the net positive and better construction in Colorado. And we'll get into what those terms kind of mean in a second here. It's frozen on me. Sorry, I seem to be having trouble with my screen. I'm going to stop sharing just quickly, see if I can fix this. Huh, that's weird. It's very weird. Preview, quick preview. Apologies. Technical difficulties.
Cillian, if you're still having trouble, I can share my screen and you can just let me know when to go to the next slide. Let me know.
Yeah, I think I got it. Let me just see if this is working here. This is weird. Apologies. This usually works, but it's not working for some reason. 2 seconds here, and then we'll try it there. All right, one more chance here.
Cillian, we can also maybe have Hannah pull it up because you shared it, and you can just tell us next slide if you want us to move it.
Yeah, I think let's see what's going on here. I think I have it, but let me just now, is that full screen? You guys see that screen?
It's not quite full screen, but we can see it.
Yeah. Apologies, this is weird. It's supposed to, usually works. Makes it full screen, huh? Play maybe. How about that?
Yep, that looks full screen to me.
Yeah, and we can go back and forth. Perfect. Okay. Okay. So resource conscious construction. Just an overview of what we're going to cover today. Just my background, kind of the philosophies and standards that guide me and that I work with. The Habitat program in Gunnison, Colorado. The project, the previous project, not our current one, but our previous home, which is the first bill that Habitat did that went in this direction of net positive. How we built it, construction techniques, the systems in those buildings, and then overview of kind of approaches for how we can apply the lessons that we learned or alternative techniques to current construction and code enforcement. So just a background of myself, I was born and raised in Ireland as an architectural technician, which is kind of like something cross between an architect and an engineer. I worked all over the US, mostly in cold climates. I have my own company, I have to design build, and I like working with natural materials just in general. Resource conscious construction is a philosophy that or framework, I should say, that is trying to be more holistic in how it considers the different elements in construction. So I never call myself a green builder or a natural builder or any of those kind of terms, partly because those aren't really, they're sort of vague, ambiguous terms, but I also feel they're somewhat exclusive. And the reality is that most natural builders, most green builders or architects, you know, whether they're LEED certified or basically do 90% of the same things, and the 10% that we do different is what makes the difference. But it's we all basically play in the same sandbox, and this is a way of helping us improve our impact in a positive way. So those resources that I just talk about is like time, money, labor, skills, energy, materials, environmental conditions, health of our homeowners, our workers, ourselves, and the greater environment. And so at Habitat, like we have somewhat, you know, we have a larger set of resources when it comes to like volunteers or people that give their skills for free or at lower cost. And so that's something else that we have to be conscious of with Habitat. Like I said, I avoid ambiguous terms. I've avoided getting certified too often in either, you know, with Passive House or LEED or Living Building Challenge, and they're all they all have their own strengths and their weaknesses. But with Habitat and with the framework of resource conscious construction, I feel like it's while it's not any kind of a official certification, it can be more flexible. And so we'll get into the project that we did in with Habitat in Gunnison, but we did our own monitoring. And so basically our own standards that we use technology to learn from. Other frameworks that I use and now Habitat uses for its decision-making is triple bottom lines, I'm sure a lot of you are familiar with. And so just seeing how we can impact through each build and through our programs, both socially, environmentally, and financially. And with Habitat, we're spending $250,000, give or take, for every one of our builds. And so that's a huge potential impact. Yeah, especially for an organization that is focused on serving low-income folks, if we can address the root cause of some of that by keeping more money in our local economy, that's a pretty important metric that we look to. Health, kind of like a health oath or a Hippocratic oath for design and construction is to, you know, the people that we're serving, you know, the people that hire us as professionals, making sure that we provide them with a home that is healthiest for them, that serves them. But in the meantime, also looking after the workers. And so being conscious of the techniques that we're asking them to do. And then in general, the greater ecological system that in the environment that provides us with most of the materials that we use, ideally as many as we can. The difference between regeneration, being regenerative, and resiliency versus doing less bad, which is kind of the current paradigm in the green building industry, is how do we use the same energy as we produce, and just kind of like quote unquote net zero. And so trying to do better than that rather than doing less bad, we can actually be part of the solution. Like I said, every build is an opportunity to do that. And we're looking not just at doing less bad, but even carbon sequestration if we can, and the overall impact of how to actually improve our site and our community with every build. Habitat for Humanity in the last 2 builds has committed to this direction. And so that's our 2019 home from the exterior. And then on the interior, you notice it's got solar panels on it. It's clad in local wood, and the interior used a combination of local lumber and straw bale and cellulose for its insulation. And the program itself has been around since the mid-90s. They built one of the fastest homes I think that was in the late 90s. They built a home from floor up in 14 hours. They provided 15 homes in the Gunnison Valley. Homeowners have to qualify, basically have to have a certain low income relative to AMI, the area median income, and then they have to put 300 minimum sweat equity hours, depending on how many family members they have. We're building 1 home a year going forward, and it takes about 2,000 volunteer hours per build. Yeah, so our approach, like I said, with our program is we're trying to provide a home that has the greatest impact in our community, but also we're trying to actually monitor what we do, how we do it, and to learn ourselves and to prove the hypotheses as we go along. So these homes produce more energy than they use, and so that their electrical bills are basically they're only paying for standing fees, and they produce enough energy to not only completely power their own homes, because these are all electric homes, including all their environmental conditioning, but also we use the excess power to power the construction on our job site next door, because we currently are building one block or one site at a time, working down a street. So some of the metrics that we use on our first home for seeing how it performs is we have temperature and humidity monitoring in all the walls, in the ground and in the roof. We have indoor air quality monitoring to make sure that the quality of the air is up to basically the highest quality that we can get. We monitor our energy consumption and production. We have a vague idea of how much money, like I said, $30,000 to $40,000 from that home stayed in the local economy. How that actually impacts the local economy, I don't know. But if there's any students or economists out there that would be interested in developing that, I have a couple of leads that this winter hopefully we'll be able to get some kind of solid numbers around how the actual finances of building locally impact not just us, but also our, how that knock-on effect happens in our economy. Same thing with life cycle analysis study. I have a pretty good idea that we're doing really well in that, but I don't have a really solid study for that. So it's an opportunity. Same with waste and enterprise generation. We're just looking at creating our own products, and perhaps there's opportunities there for new products to be developed. And we're at least going to monitor each one of our homes for a couple of years. The home that we built in 2019 was a 2-bedroom, 1-bath, 1,000 square foot home. It was a $230,000 cost of the homeowners, and that included land, contractor fee. It took us about 8 months to build it. We focused on local materials, like I said. 90% of the material was from within 100 miles. We used straw, cellulose, wool, hemp, and the windows were made locally. The windows are made in the Front Range. The metal was rolled in Montrose. The cabinets were made in the Front Range. And so we really tried to focus on either grown, processed, or produced in Colorado or within 100 miles. We did energy modeling on the home before building it. And so the peak heat loss of this house is 6,000 BTUs per hour, which, to give you some context, is about 20 people doing yoga at 20 below to keep it at 70 degrees. So basically, in the case of a complete power outage, this home will never drop below 50 degrees, even without anybody in it. And so we're actually looking at a frost-free house. That's not only low energy, but high level of resiliency. Yeah, the average energy per year is really small, and that allows us to have a smaller solar system on our home in order to get the energy that we need to run it. And so we have an average size solar system on that house, but because of the low load, we have enough to power our build and even electrical generation or electrical vehicle charging if we need it in the future. It's a super high performance home, really airtight, but is vapor open. So it's very breathable, quote unquote, meaning it has fresh air that's controlled through ventilation, but it allows the envelope to dry if any vapor does condense in there throughout the year. It's able to dry seasonally. The house is foam free. We try to reduce as many fossil fuel or oil-based products as we could. There is actually a tiny bit of foam in our windows, but other than that, the entire envelope is foam free. We have very few manufactured wood products, so there's very little formaldehyde. PVC was in the plumbing, but we minimized that as much as we could. And in our heat pumps, which are extensive in our home, we made sure we load GWP refrigerants. GWP is global warming potential. So GWP of carbon is a GWP of 1, but a lot of refrigerants in air conditioners can be several hundreds, if not 1,000 or more, in terms of their greenhouse gas warming potential. All our appliances are really efficient, and so are our systems. Like I said, our house is freeze proof. We certainly didn't do this alone. We've been very fortunate since we started this project to make very valuable connections with local programs that are doing fantastic work and are really supportive of what we're doing. The SOAR program in Crested Butte, and the students there, high school students, before I was even hired, started designing the home. And so I worked with them a little bit to integrate their designs into the final product. We're hoping to do more of that in the future, and excited about how to bring those students on site in the future. The Gunnison High School students, similarly, every year for Habitat, they've built a shed for us. This year, we're working with them and Mountain Roots to build a greenhouse instead, which by default is a shed. So we're pretty excited about that. They're actually going to come visit the site on Wednesday. Mountain Roots have been helping homeowners to make their gardens more productive. Again, we're excited about that to develop. And Western University, the MEM program, and various professors and students have come and volunteered, but also Rich Strongberg in particular has been a valuable asset in monitoring our homes and being a real scientist behind my kind of pseudo science. And the Cold Harbor Institute has just in general, but amazing potential for working together in terms of developing educational opportunities where we could train students through the Institute, but also have a classroom of Habitat for each of our builds to create an educational program. And we're just starting to talk about that. And Equitable Solar Solutions, a program of Cold Harbor, has been providing us with solar, and again, with Rich Strongberg as leading that program. Here's just some of the other partners that were involved, and I'll skip through that. So, a lot of information. Any questions? Are we on time? We're kind of on time.
And I wanted to remind people too, you can post your questions in the chat box. I'll be sure to monitor that if you don't want to be seen or heard through video or voice.
Really, no questions. Must be good. Oh, we got one. Okay, I'll continue. Does that sound good, Hannah?
That sounds good, Cillian. Thanks.
Okay. I guess we're on time. All right. So the techniques that we used in that particular build, we we kind of went all out, partly because we had homeowners that were specifically requested from Habitat a straw bale home, and sort of the elements were right. The board was ready. The director who'd been pushing for it for a long time, Julie Robinson, sort of like had all the right elements lined up. And when I first met the homeowners, they wanted a straw bale home, but I suggested, we can do more than just add straw bales to a conventional home. And so they were very game and very ecologically conscious people and hard workers. And so it all kind of fell into place. And so natural building, quote unquote, is certainly, if you're working with raw materials, just inherently is going to take more labor. But with Habitat, we have free labor. And so the cost, we can kind of offset costs. So it's a little hard I know someone's going to ask me how much these homes would cost out in the real world at some point tonight. And it's really want to have those numbers, but just don't have a great way to quantify it right now. But I always try to start by building something the way I think it should be built, and then figuring out how to do it faster and efficiently. So with this home, we definitely wanted to just go all out, make it as ecologically sound as possible, as high performance as we could, and also aesthetically pleasing. So what you're looking at here, this is the floor system, which is all Doug fir from the San Luis Valley. It's a 16-inch deep floor system that got filled with cellulose insulation. On the right-hand side, that's lath and plaster, like a traditional wood lath. So we had a very fortunate volunteer that ripped a lot of that wood out of some of the poorer quality lumber that we got, and then we plastered it with clay plaster. This clay ended up coming from the Front Range. Some of it came from Tamichi, and then the sand is all from the Tamichi Basin. I mentioned earlier that the envelope has a breathable wall system. And like I said, breathable isn't a very technical way to describe it, but essentially what you want in an envelope is one that can deal with moisture. And you also want to have fresh air in your home to be able to physically breathe. And those are two related but different things. And so with our home, one of our hypotheses was we were trying to build the most affordable high performance envelope we could. And in my experience, the way to do that is to basically make a bag around your home and to have it as vapor open as possible, which is what usually people mean when they say breathe. So that means if any vapor, any moisture does condense in your envelope, it's able to dry seasonally, or it's able to hold that moisture seasonally without any problems. And so in this dry climate, we don't need to have a vapor barrier in the interior, which was part of our hypothesis. And so wood, straw, cellulose, recycled paper, hemp are all very similar makeup. They both contain a lot of cellulose and lignin, and they essentially are almost the same materials or have a lot of the same elements in them, but they're just assembled in different densities and different patterns. And so wood, straw, and cellulose all behave very differently. I'm actually speaking out of turn a little bit. Not super familiar with hemp, but I imagine it performs similarly in that it can get wet, but it can dry easily. And so as long as it has the ability to hold that moisture and then the ability to dry seasonally, and it doesn't get into a point where there's any kind of bacteria forming or rotting or anything like that, then it's a pretty bomber roof system. I avoid using spray foams, plastics, petrochemicals that tend to trap moisture because in all my experience of especially retrofitting homes, what I found is petrochemicals and non-vapor open materials are way more likely to trap moisture than they are to prevent a building from having moisture issues. So in this home, we actually don't have any sheathing. So we have essentially a rough wood lumber frame. We wrap it in this Gore-Tex, this black material, and then we put a diagonal bracing over that for our shear, which is typically what sheathing gives you, is shear as well as something to nail to. But our bracing allows us to nail our siding either vertically or horizontally to that diagonal bracing. And that serves two purposes, well, a bunch of purposes, but from a vapor perspective, it creates a rain screen, which means if this is a fairly flexible building technique, and so you could use this somewhere like Seattle, which is a lot wetter climate, where you get a lot of rain on your siding, and that cavity behind it allows any vapor that gets into the siding to dry behind it. And then in our situation, any vapor that comes from the interior and condenses in the wall is able to dry from the inside. So it's a double, that cavity serves two purposes now, venting. Here's some of the insulation details. We built a straw cellulose hybrid, and so we built a pretty standard stick frame. Well, not standard, but we built a stick frame, 2 foot on center, like I showed, without sheathing. We filled that 6 inches with cellulose, and then we strapped our bales to the interior. So in our climate, which has a high heat demand, a single straw bale has disadvantages in terms of performance. It's about an R30 wall, give or take. A lot of factors, the density of the bale and how it's installed, etc. And then you have to plaster both sides. And so in our climate, we have a short season for building. And so by building more with a more conventional exterior, we can avoid plastering the exterior, which would be, we have a limited window for doing plastering, because you don't want to plaster in the winter, because any wet trades, you'll have freezing and cracking in your plaster. And so this way we can have a more conventional exterior. We can get an extra 6 inches of insulation, which bumps our wall up to R50 instead of R30, which makes a huge difference. And then, but then we get the advantages of the straw bale on the inside. We put 2 feet of cellulose in the attic, which is R83. We put wool instead of spray foam around our windows. We used donated denim for soundproofing on our interiors, as well as some straw clay and other natural building techniques on our interior walls. On the left-hand side, you can see that's a big hammer. One of our volunteers is bashing the straw bales into the walls. And then the right-hand side is our north wall, which that's the inside of our north wall. And that is 20 inches thick, and that's all cellulose. Part of that was just to have a different wall to be able to monitor. And then also just the straw bale takes somewhat longer to install. And so we just figured we'd do one wall all cellulose. Just here's a few more details of those interior finishes. So you can see once we insulated the 2x6 frame, we added the straw bales to the interior. But you still have to add framing for window bucks and basically support, like the clay plaster. One of its disadvantages is it doesn't set up quite as strong as something like a gypsum or a cement, and so you're limited somewhat with some of the details. So often cob houses or adobe homes and straw bales often have a lot of rounded edges, because that's the best way to use that material. I've avoided that in my work just because I have a mission to try and make these ecologically sound building practices more widespread. And if the aesthetics are important, and people will, I believe, will look at, and I've heard them look at round straw bale houses and be like, well, it's cool, but I don't want round, I want straight edges. So I focused on trying to make homes with the same techniques that are more palatable to a more conventional aesthetic. But as you can see, behind the surface, we've got straw clay, we've got like traditional techniques of lath and plaster. That middle center or center lower photograph is a bunch of Western students, and actually I think that's your county commissioner there too. I think that's Liz in the middle, who brought those students over. And then you can see on the right hand side lower that I actually used the lath over the bales as well, just so, again, like I said, we get a nice flat aesthetic and not have that round bale effect, so it looks more like a conventional construction. And this is a finished home. We actually Habitat International actually gave us an award last year for category they created for us called Best in Low Carbon Footprint, to kind of recognize what we had done. But also afterwards I discovered, because that's the direction Habitat International is going, and they not quite to our length, but they're looking at their full impact. They're not just looking at energy efficiency, they're looking at emissions and toxicology and improving their codes and their recommendations in general as an organization. And as the 10th largest builder in the US, Habitat is quite a strong, it's a lot of building for one, but also in terms of how they influence communities. They're a fantastic way to disseminate this kind of approach. So I'm pretty excited about continuing that. And since we kind of got this recognition on the state level, we've had a lot of visitors from other affiliates, and in fact, Chaffee County in particular was pretty excited to follow some of the things that we've done and indeed learn for themselves and try their own version. But as you can see from the pictures, nothing doesn't look too crazy. It looks fairly like a fairly conventional home, and yet we were able to achieve that with predominantly local materials.
Yeah, Cillian, we do have some questions if you don't mind taking them.
Sure.
Davis, he said that you mentioned hemp, but said you're not familiar with it. Is that due to the costs or availability or the effectiveness of hemp? So it sounds like he's asking, why aren't you as familiar with hemp potentially? Is it not?
Sure. It's not something that's been available to me. I've only been in Colorado for 4 years and 5 years. And most of the time I was doing conventional, or half the time I was doing conventional construction. And it wasn't something I was familiar with. One of the problems with hemp is, there's pros and cons. And so straw bale is readily available and it comes kind of already pre-packed. Hempcrete doesn't have the same R value as straw. I think it's more appropriate for warmer climates because it has that low R value per inch. I think like with our homes, with our straw, we're getting R50 out of straw bale cellulose wall system, which is 20 inches thick or 19 to 20. To get the same out of hemp, you probably have to, probably go, I'm not sure exactly the R value hemp off the top of my head, but it'd be more. I think it'd be at least 20% thicker, if not more. And so it's just not as high performing. If it's available locally, we actually did use some in our current build just as an experiment because somebody gave us, another natural builder gave us a couple of bales to experiment with. But that hemp came from either Canada or Europe. So it's not super available right now. I know that there's a couple of conferences coming up that I'm attending. I know that hemp is starting to like get more momentum. But hemp is, I think it's kind of sexy and not necessarily fully thought out for this extreme climate. Like I said, I think it favors warmer climates. And it still uses lime. And so one of the things to be aware of is like, as we look at these new materials, we have to really give them the same critical analysis as we would any other material. And so one of the things that with lime and even lime plasters that's kind of often ignored or not really given much credit or much prominence in the conversation is that cement is really impactful. Concrete is really impactful. And that's because of the cement and the steel. The largest carbon emissions from cement production is from the production of lime. And so if you're using hempcrete and you're using lime or you're using cement as your binder, that can have pretty big impact actually. It's not necessarily sequestering carbon. And there are better cement technologies coming along now. But historically, those materials have a high impact. You know what else is grown in Delta? Well, not Delta, but Fruta. We get our straw bales from Fruta. And the other thing too is like straw bale is a waste product. Hemp, there's a variety of different uses for hemp and a variety of different kinds of hemp. And so it's not, again, super familiar with it, but the people I talk to when I'm like trying to get them to, see where their products or their waste products can work into our building programs, they're just like, well, it's, like textiles, for instance. I would love to be able to use hemp for textiles, but textile industry has left the US a good decade or two ago. And that's one of those things that hemp from, you have to grow hemp for specific reasons. Like you gotta grow it for rope, you're gonna grow it for fiber, and there's nowhere to process it currently that I'm aware of in Colorado. You could use scrap from waste products from not from THC. So like, yeah, it's a whole different world, especially if you're dealing with like THC and things that have to actually be destroyed and can't be reused. So anyway, not an expert, but open to any information anybody has on that.
I guess another question too, regarding kind of your process of kind of what the house will look like in the end, like what exactly is your process for that, of like, where do you get your influence and your inspiration for what a house will look like ultimately in the end?
Well, I've learned a long time ago that the best way to design is to just be an open a sponge for the people around you and the people you're building for, to be more of a guide than an oligarch of a designer, which yeah. And so the process really is fairly organic. I have an idea of aesthetic and things that I like for sure, but I find it way easier and more productive and just in general more satisfying to have it be a process of guiding a homeowner or students, whether it's education or a design, to just sort of try bring out what ideas they have. Because especially with students, if you have 9 out of 10 students are probably not going to come up with anything too original, but that one student at 10% or 20%, it's gold, because it's just something you never would have thought about. And so that process is very organic, and it takes a fair bit of experience to be able to be confident in that process. Well, experience specifically in doing that. And so I was very fortunate to come through the sort of design build world after kind of getting out of architecture. I worked in design build, and that taught me a lot. And particularly in the Estermaro School of Design, design build school in Vermont, that's sort of their whole MO is the design build process. And I learned from some of the best professionals in the country really there. So yeah.
Are there any other questions? I think Cillian, I think you have some more, but are there any other questions before Cillian continues? Oh, yeah. I don't know if you can see that, Cillian.
Legislation, policy to implement local, state level. That's a fantastic question, and actually a conversation that's just beginning. I'm trying to reach out to as many people in the community up and down Valley about how to take some of the projects or some of the issues like the LUR, the housing crisis, and to get those people to sit, to look bigger rather than like, how do we get housing now? It's like, that's important, but how do we get here, and how do we avoid it in the future? And so there's actually, like I said, very nascent conversations between different stakeholders from all across the Valley that I'm hoping to get into in the next couple of months, and maybe really try crank it out this winter. And code is a really important one. And that's tricky, just because code enforcement, some people bristle at more code, and how to approach that's really important. So that's like the tricky part, is not how do we make code force people to do things, it's how do we get people to understand the importance of these changes, and code is one lever for doing that. But I've certainly got a lot of ideas for things that are really simple that can make a huge difference in energy efficiency and the health, the interior air climate of our homes. Because that's the thing, we're building really tight homes, which I think we should increase our standards of. We're not just saving energy, we're also getting a huge increase in comfort, but most importantly, we're controlling our interior climate. And going forward, that's something that's going to become more and more important. And in the last couple of years, with forest fires and COVID and just increasing in pollution in general, that's a pretty important thing to focus on, is our interior health. or the indoor air quality in our homes, because we spend more time in our homes breathing than anywhere else probably. And to be able to control that, particularly like in a place that's only unfortunately going to have more fires, our homes are highly controlled. And I think that's something that the way the industry should go to. And there's easy metrics for that. All right, well, I'll continue. I don't have a huge amount of time left, but just to give you an idea of our systems and how our homes work, because this is technology that is happening, particularly engineers in the last couple of years in the Valley, some that I've worked with, are starting to get all excited about heat pumps, which is great because heat pump technology is the future of America, but it's kind of the present for Asia and Europe for at least a decade, if not 2 decades. And how we do that is pretty important. One of my hesitations about going all into it is like engineers tend to think, okay, we can keep building pretty much conventional construction and we can just engineer our way out with these new systems. I don't think it's either or, I think it's and both. I think we need to make our homes more resilient. And because like I'd rather put money into the envelope, make thicker walls that insulate more, make them airtight, because there's a bunch of advantages that, like I mentioned a few minutes ago, and have heat pumps and systems that require little energy, but those can also be smaller and more affordable if we reduce our envelope. So the homes that we're building for conventional cost, for the same cost as conventional construction, but we're horse trading, we're moving money from our systems and our bills into the envelope. So our envelopes aren't cheaper, but they are pretty cheap, but we're saving money in other places and putting them into the envelope, which all hopefully will last for 100 years. And that's what we're looking at when we're building these homes. We're like, how long is this building going to last, and what will happen to it in its lifetime? And so I get into that altogether. That's a big conversation about materials. So, but our thermal envelope, except I like to put that our money and our energy into that first before anything else. And so like, so this building is basically passively heated from the ground and from solar gain to keep it above 50 degrees. And I don't think it would, even if you didn't have any passive solar, I don't think it would. I think the ground heat that it captures would probably keep it above freezing too. Our windows, so an easy place to make big energy savings is our windows and doors. And so if we were able to mandate higher performing windows and doors, that would be a huge step, because they're essentially holes in our envelope. So, if we make our walls 20 feet thick with insulation, our windows are still a huge heat loss. So at a certain point, improving your wall systems or your envelope with insulation, you're getting no gains or very little gains compared to air tightness and improving your windows and doors. So this home, and actually we just did a blower door test a few weeks ago on the current home, are some of the tightest homes in the county. But at least the tightest ones that I know of that I've tested. We do all our own energy modeling and air testing. Like I said, having if we have a normal home that has really efficient systems, those efficient like air or heat pumps, those systems can break down, and the home itself then is not as resilient. By putting our energy or our money into the envelope and our resources, by default, we have a very resilient home. This is sort of the Dr. Zeus that runs the whole thing. And by having low energy demands or low heating demands, we're actually able to have fairly simple systems. It doesn't look simple. So basically, our home is heated by a single HRV system, which is fully integrated. It provides heating, cooling, humidifying, dehumidifying, and air filtration. It uses a heat pump, so it's not your typical HRV. It uses a heat pump to extract the energy from the exhaust air and then transfer it to the incoming fresh air. But because it uses heat pumps, it's able to control humidity as well as do air conditioning, which this home has never needed, I should mention. The homeowners had it set at 80 degrees, and since in the last 2 years, the home has never passively gotten above 80 degrees in the summertime. Our hot water is heated from an exterior heat pump that uses a CO2 as a refrigerant, which has a GWP of 1, because it's basic carbon dioxide. And so that's as good as you're going to get in terms of a heat pump. It's a pretty expensive unit, but it's super efficient, really effective, and actually will work down to 30 below. So that'll still produce heat, not super efficiently at that temperature, but it'll still produce heat at 30 below. This is a mechanical room, a dedicated mechanical room. That's something that I think we should really look at in terms of code, is having a specific room in our homes for mechanicals. And it can always be used for storage, but it's a good place to basically have the bridge of your home. Plus you can play hide and go seek. The design process is really important. I think with the technology that we have with three-dimensional design at this point, designers, architects really should be integrating systems and doing energy performance as part of their service, so they can actually understand how the building is going to perform. We haven't always had that technology or those tools, but they're pretty readily available now. And so I think at this point, there's no excuse for the designer being responsible for not only the energy efficiency, but also if they're specifying materials, the environmental impact of buildings. Basically, our home has a balanced ventilation system, and that's what provides all the heating and cooling, which means we bring fresh air into the home, into the bedrooms and the living areas, and we extract it from the laundry closet and from the bathroom where we have stale air. These are some of the monitoring systems that we have. We have sensors in the walls on all 4 sides, and in the ceiling and floor, and in the ground, in fact. And just in general, I always have just cheap, Amazon $5 or $10 like humidity and temperatures sensors around all my job sites, just to help people get an understanding, and myself indeed to get an understanding of how buildings perform. On the left-hand side was our blower door test for this home. That's the metric is how much air does the house leak at a certain pressure, which is minus 50 pascals. So that is 70. You're very unlikely to find that in an existing home. The average home is probably more like 1,000 cubic feet. So that we have 70 for that. The center middle or center lower picture is the control center for our environmental systems, basically a HRV system. So you can set your temperature, your humidity, and that you can also just put it on smart mode, and it'll just keep it where you want it to be. And then the bottom right is our air quality monitoring, which is more, it's a handheld device. It's not a continuous data logger, unfortunately, and those systems cost a lot of money. So we're looking to do that for our next home, but we were able to get a pretty good idea of the air quality in our homes. Basically, when we would cook, if we put this next to the stove, it would start to spike, but within 5 minutes of finishing cooking, it would clear again, because we have, while our house is a balanced air system, we do have exhaust air for our cooking that has a makeup air. So basically, while the centralized ventilation system brings in as much air as it exhausts, our kitchen vent hood exhausts but turns on an electronic duct that allows fresh air to come in through the crawl space, mix in the crawl space, be sucked up through the refrigerator, which makes the refrigerator more efficient, and mixes the air somewhere where you don't feel it, so there's not really a draft. That's a pretty important thing to know in this home, because cooking effluent is fairly impactful, particularly if you have combustion, but we don't have any combustion in this house. But that's the biggest air quality risk we had in this house was cooking, which is pretty typical. But even then, our systems clear the house very quickly. All right, any questions on that? I know we're running out of time. Do you see or know of any new promising material technologies that would improve current builds or further improve future builds? From Anna Markey. So Anna, we're actually, in my opinion, at a super lucky time in history that we have all the technology we need to do so much better. What we don't have is the will or the awareness. And so I would say we don't need any more new technologies. It doesn't hurt. And certainly like improving the technologies would be, it's going to happen. So particularly heat pump technology, I would like to see that HRV system that we have in the first home have a larger heating capacity. There's competitors that do a bunch of really cool stuff like integrated air quality monitoring and smart sensing, where they basically don't refresh the air in the house unless they sense the CO2 levels. Super smart. And I'm pretty excited to get my hands on that HRV, but it has a lower heating capacity. So heat pump technology, being new to the US, is still kind of figuring out some of the kinks and figuring out what strategies for approaching the market. But we have the vast majority, like even 10 years ago, we didn't have the technology that we have now. We basically have no excuse. We are technology rich and material rich, and we have the building science now to support all these theories that crazy hippie builders have been talking about for years in terms of clays and natural materials. Like we actually have the research now to show that, yeah, clay, as an example, clay creates really good air quality in your home by deionizing and basically cleansing the air inherently. But we're also having continual air turned over in our homes as well. If anyone has any more questions, I can go to the next slide, but I think I've covered a lot of it, and just jump in if anyone has any questions. But questions like, yeah, how do we start implementing this? Code adaptations and enforcement is certainly one way to do it. You just have to be intentional with how you do it and make sure that you have that you bring as many people in, and that you you don't phrase it as enforcement, you phrase it as a tool for improving basically quality of life in homes. Got a quick question from Valida. This year's house, just actually got it closed in today, so we're totally air sealed. We have our high performance windows and doors in. We have half of the plaster in our home in. We have kitchen cabinets in. We've got to finish the insulation, but we have a month and a half or so, and so we're looking pretty good. But we could always use a hand, and anyone who's online is always welcome to come, and I can explain or show you what these things are or what they look like in practice. Just looking at our air barrier, it's pretty important that our air or vapor control layer, which is another way of saying air barrier, is complete. I think that's, in my experience, that's the only way to guarantee a good home, is to make sure you have basically a bag around your house in some form or another. Increasing air tightness can help a lot, but if people are using spray foams or other petrochemicals to do that, I question their impact, but also their efficacy over time. Spray foam in particular has been shown to test really well once installed, and 2 or 3 years later not test anywhere near as good. In the meantime, that means not only is it not performing as well, but it's allowing warm, moist air to condense behind it or in and around it, which is very dangerous. And I'm worried about the future of spray foam cathedral roofs in general. Improving the windows and doors is a simple way to improve our standards. Discouraging toxic materials, particularly ones that are made by massive companies that have been very irresponsible environmentally and ethically over the course of their time. Dow comes to mind. They like to sue rather than to research the effect of their chemicals. And I think I've kind of covered everything there. Creating a mileage sticker for new buildings would be important too, but that's kind of part of code enforcement as well. And then making homes either solar ready, or actually looking at just making all homes net zero or solar net metering ready. And then in general, just being more scientists and less just taking either material standards or codes verbatim and actually questioning. I think that's part of how we have to shift our thinking. We can't get ourselves out of this problem by using the same thinking that got us into it. We have to train the next generation of design builders to think for themselves and to create tools that can help them analyze their hypotheses, like we've been doing with our habitat home. There's really strange things that I've learned by just looking at the data, and still things I don't understand, but our homes are performing better than we'd hoped, actually. And again, a huge credit to Rich Stromberg and his students for helping with that. Any questions? And then I'll just, there's a bunch of really cool online resources and great people doing great work. If anyone wants to ask more questions, basically from the people I learned anything I know from.
And I had a question regarding already built homes. I know I think you've slightly touched on this by having energy efficient, doors and windows. Is there anything else that people can do to improve the efficacy of already established built homes?
Absolutely. And actually, there's a lot of affordable programs for that, which can either fully pay for or subsidize. GV Heat, I'd recommend looking up GV Heat. They administer a few different programs. They do the CARES program, the weatherization, what does it even stand for? WAP, W-A-P, there's the Green Deed program. And that's part of something my business does also, is we do deep energy retrofits, working with those affordable programs. We're also getting into radon work, which radon mitigation from a health perspective is an important, really important thing to do. But actually we can get multiple benefits by doing radon, particularly in new buildings, but even in retrofits, we can make the house, have a lot less radon. We can make the house more airtight, and we can prevent vapor from getting into crawl spaces if we are able to get access to a crawl space. So there is lots of good work to do there, and GV Heat is a great resource for that. Like I said, even if you don't qualify from an income perspective, they're a good place to start with that, or just call me. We're trying to actually train at the moment. We're trying to increase capacity. There was just an article that KBUT covered, and they interviewed Giza Michael, who runs the GV Heat program under the Gunnison Housing Authority. And we're trying to train more people locally to be able to do that. There's funding for training. There's a lot of need. And as if any of you have ever lived in Gunnison or rented in Gunnison, I'm sure you know there's great need for improvement of the housing stock, and there's money for training. So if anyone's interested, please reach out to me.
Right. All right. Does anyone have any other questions before we wrap this up? Cillian, are you good, or did you need to present a little bit more?
Oh no, I'm good.
I'll make sure. I don't want to cut you off at all.
No.
If I don't think there are any more questions, but I'll echo kind of what Cillian was just talking about, and he has his contact information. Cillian, I am going to stop sharing your screen if that's okay.
Absolutely. Yeah.
My screen. And again, for those that are still with us, he provided his contact info, but I also want to provide my contact info as well. So I'm going to share my screen. I'm going to start, if you don't mind waiting 1 second. As Cillian offered his contact information, I offer you mine as well. If you have any questions, comments, suggestions for future webinars, I value feedback for sure. And then I also just wanted to offer up the opportunity, as you all most likely know, this webinar is free to access, but we're what we're trying to do is implement a pay what you think this experience is worth scale. So if you feel that you've gained something from this webinar and are in a place to make some type of payment, you can do so through visiting our website at coldharborinstitute.org. And I can also provide the link for you right here. Every little bit makes a difference. So again, if you feel that you can and you want to make a donation to Cold Harbor, you're more than welcome. So I'll post that right in our chat.
Wait, somebody from Alaska.
Yeah,
Cool.
that's so cool. Yeah, that's a good reminder, Cillian, looking at kind of people's backgrounds, because we kind of had a bit of a mix, which is kind of cool. But before I guess we do that, I do want to say just a huge thank you to you, Cillian. I learned a lot through this experience, and I
You're welcome.
deeply appreciated your time. And if anyone has any questions, you're getting thanks from a lot of people. I don't know if you're looking at the chat, but you're getting lots of thanks from people as well, which is super cool.
And thanks, yeah, thank you for the opportunity, Cold Harbor, and you, Hannah, for facilitating this. Always happy to talk about. Always have to have people come visit the site and see what we're doing. You know, it's a lot of information, but yeah, we're really looking for partners and people to, you know, just tell your friends what we're doing and apply for Habitat, because funny thing is we don't actually get that many people who apply, and so I think they don't necessarily understand what we do, and I really appreciate this as a